This is Remotec's newest and most versatile platform, the Andros FX. It was designed based on scenarios and customer feedback where capability gaps were identified, mainly related to being able to defeat a vehicle-borne improvised explosive device, VBIED, remotely. FX looks big, and although it is heavy, weighing it at 1,000 pounds, it actually has a smaller footprint than our F6 series. The tracks fold up 90 degrees where F6 only folds to 45 degrees. FX is 42 inches long and has a 48-inch turn radius. It's the same width as the F6 with tires, 28 inches. We focused on 4 main areas during the development phase of FX. First was mobility. We recognized the limitations in some of our existing platforms and wanted to make improvements in the ability to operate in many different environments and surfaces. FX has performed well in fine, loose sand, wet leaves or mud, as well as snow. The robot has 4 independent drive wheels, which really helps maintain traction, and each of those has a mechanical release where if the robot experiences a catastrophic failure, or if the battery dies and it needs to be recovered, by mechanically releasing the drives, the robot can be pushed, pulled or towed back to the transport vehicle. Each track is over 5 inches wide, and when they are positioned parallel to the ground, it creates a big surface area with the overall length at 73 inches. This makes FX a great stair climber since it's touching 4 or 5 stairs at one time, and the weight is distributed over the length of the platform. It's capable of climbing inclines and stairs up to 45 degrees. Also, because the articulators have an increase in length, the FX can overcome obstacles up to 25 inches high without assistance from a ramp or step. Although it does take some skill and practice to minimize damage to the robot, we've demonstrated the ability to climb up and over a Jersey barrier which is 32 inches tall. At least you know if you had to do it that it could. The left and right side articulators are no longer mechanically tied together. Each articulator has its own motor and gear package assembly. They can be used independently so that if the robot is traversing uneven terrain, the articulators can be positioned in a way that not only stabilizes the platform but also so that the arm can still be operated off of what would have been the low side of the robot. The batteries are also located in the chassis. We are using 3 lead-acid batteries configured in series for 36 volts. Runtime is between 2.5 and 3 hours based on a typical mission, and the batteries can be charged either inside or outside of the robot. 4 thumb screws secure the battery pack, making it quick and easy to remove or swap, and having the battery pack inside the chassis and low to the ground really helps the center of gravity for increased stability. Second, on the manipulator. The increases in capability include the reach and lift as well as 2 additional degrees of freedom. The arm can lift 275 pounds right in front of the chassis. At full extension, the arm is over 8 feet long and it can lift 125 pounds. Being able to reach farther into a cargo vehicle, pickup truck, etc., and be able to lift a significant amount of weight such as propane tanks or moving barrels is a tremendous step forward in helping to defeat VBIED threats. Also, when the robot is on its toes with the articulators all the way down, FX can reach something at 11 feet. This is really helpful for working around a tractor trailer or just being able to have surveillance at that height using the cameras located around the gripper. One huge advantage over our previous platforms is being able to fully extend the arm away from the robot with the articulators all the way down. FX is very stable on its toes and can even move over 50 pounds, the range of the torso left to right with the arm fully extended. Lastly, the real differentiator with this arm is the addition of the 2 roll joints between the shoulder and elbow and wrist. Think about working around a vehicle. With a linear arm you always have to consider the angle of approach because of how a car door opens and swings, and then, in most cases, you are limited to only the compartment of the door you've opened because of the limitations of the arm. And, we all know that the vehicle is never parked in an empty parking lot with no other cars or obstacles around it, so it's almost impossible to have the necessary space using a robot with a linear arm. Having the additional roll joints allows you to position the robot parallel, in front of, behind or in between vehicles but work completely perpendicular. Once the robot is positioned, there is no need to continuously move the chassis and risk bumping into or moving something that you didn't intend to in order to complete the mission. Also, having these roll joints means that you can access spaces where the body of the robot may not fit, or that you don't have to dedicate the robot to a space where you could instead position the arm, Either use the cameras for surveillance or to retrieve an object. There is now a camera in the palm of the gripper which gives better perspective of an object, as well as having a white light, and IR emitter alongside, and a range estimator that shows distance to the object up to 34 inches. This really reduces the time it takes to retrieve an object. The fixed arm camera is wide-angle color. It has a 115-degree viewing field. Having the ability to add a second pan and tilt camera in place of the fixed arm camera becomes really important, since this arm is capable of reaching around corners, where the pan and tilt on the mast would be useless, and the standard arm camera is in a fixed position. In order to look around you would have to physically move the arm, but adding a pan and tilt camera gives you a 360-degree view. The accessory interface mounts are new and different from our previous platforms. However, we maintained the ability to retrofit all of the legacy accessories, with the exception of two, by providing an adapter block with the system. The two accessories that can't be carried forward are the disruptor mounts and the shock tube initiators. Since this arm is designed with zero backlash, we needed to implement a compensated mount so that the recoil from firing a disruptor did not inflict damage to the arm. The shock tube initiator is typically mounted between the shoulder and elbow, and the wiring is ran to the tool ports on the end effector. Having the additional degrees of freedom in this arm allows for many different configurations where managing the wiring from the shock tube initiator would be very difficult, so we at Duke Pro changed the design to incorporate a Picatinny adapter that enables it to be mounted to the Picatinny rails on the upper arm. Now the initiator moves with the tool ports and the wiring doesn't need to be managed. FX has 6 tool ports plus a connector for the breaching tools, shotgun and SL6. 4 tool ports are located on the upper arm and 2 on the chassis for deploying off the body of the robot, towing a trailer, electric brake release, etc. When the arm is in the parked position, the elbow sits over the main electronics. We've designed a mechanical release handle for the torso so that if there is a need to access the electronics for troubleshooting, or repair because the robot isn't functioning, then the arm can be mechanically moved out of the way. The camera mast will extend 24 inches, it's chain-driven with a single actuator. The entire assembly is bolted together. We took the opportunity to improve the previous design so that if it got damaged it does not have to return to Remotec for repair. The previous design required a complete disassembly, cutting wires and then welding. This is a much simpler design and can be repaired in the field. The pan and tilt camera is a color camera with 360x zoom, 10 optical and 36 digital, which is fantastic for seeing objects at farther distances. It is autofocus, auto iris and night vision capable. An optional thermal camera can be added into the housing of the pan and tilt camera, which is great for identifying people, vehicles or anything else with a heat signature. A second thermal camera can be added to the optional second pan and tilt for the arm as well. In the standard configuration, the robot is equipped with 5 cameras. 2 drive cameras, front and rear of the chassis, pan and tilt camera, fixed arm camera and palm camera. However, it's possible to have up to 9 cameras on the robot at one time with the addition of 2 thermal cameras, a tool camera, and the camera used with PowerHawk. The 2 drive cameras and the palm camera are the same cameras. They are color cameras but automatically switch to black and white in low light conditions, so you get the best of both applications. Each camera has white lights and IR emitters positioned alongside for illumination in dark environments and also to remain useful when IR is activated. The system is equipped with 2-way audio. The communication links for FX include radio and fiber. The fiber assembly has a 2,000-foot spool of military-grade fiber, the same as we have used on previous platforms. The radio is 5 watt and requires licensing for the video frequency only. The modules used are transceivers, meaning they both receive and transmit. The radio performance spec is 1000 meters line of sight LOS and 500 meters non-line of sight NLOS. Both the radio and the fiber can be mounted on the vehicle at the same time so that in the event one fails, communication to the robot remains intact. The third area we focused was on the user interface. The Operator Control Unit, OCU, for FX consists of a 23-inch touchscreen monitor, breakout box, AC to DC power supply, CPU and a game-style controller. The breakout box acts as a junction box to manage the cable connections for the communication link, controller, power, etc. It has multiple USB ports and an HDMI port for piping video out to an external monitor or DVR. The OCU can be powered by either AC or DC, and the power supply is only required if the controller need to be operated on AC. The power supply converts AC to DC. The CPU is the brain for the control side of the system. The power supply, breakout box and CPU are bolted together and can be mounted inside the response vehicle either on a wall, countertop, etc. Also, if there is a need for the OCU to be portable, all of these components can be packaged in a Peraton case. The Peraton case includes 2 hot swappable BB2590 batteries for DC power with a runtime of over 6 hours. As the batteries are depleted, each one can be swapped with a fully charged battery without having to power down the OCU. The antenna array can be removed from the console radio assembly and mounted on the lid of the Peraton case as well. The robot is operated using a game-style controller, and while it may be comfortable in your hand, there aren't many buttons and none of them are labeled. We recognize that most public safety squads are part-time, training is typically reduced to 1 day a week, sometimes even 1 day a month, and not just for robots but all of the EOD equipment. That drove us to spend a lot of time designing the graphical user interface. It's very intuitive and doesn't require the user to go more than 2 layers deep to access anything, which results in higher retention and makes it easier to pick back up during longer periods of non-use. The avatar is real-time 3D, which really helps when the extra degrees of freedom allow the arm to move behind one side or the other of the robot. The avatar can be rotated, moved or resized on the screen. Since the buttons of the game-style controller aren't labeled, when they are pressed the corresponding joint on the avatar highlights, which gives the user a visual confirmation. This makes it easier and faster to learn the button layout. The avatar gives the user a lot of information. Not only confirming selection, but it highlights a different color when an arm joint or articulator reaches its end of travel or when there is a failure. The robot is equipped with self-collision, meaning the arm, articulators, communication links, camera extender and pan and tilt cameras will not collide with each other. This information is also displayed on the avatar. The audio, lights and IR are enabled via the touchscreen, and cameras are selected using a rendition of the robot with the cameras in their actual position. Up to 4 cameras can be viewed at the same time, as well as having the ability to make a single camera full screen or having 1 full screen and up to 3 additional in picture. Those can be resized and moved as well. All of the advanced behaviors are selected from the touchscreen, including 24 factory presets, split between 12 for the arm and 12 for the articulators. Those include stair climbing and various arm poses. There is an auto-sync icon for both the front and rear articulators, so that if the left and right sides are used independently, they can be resynced automatically. The arm has a retro traverse feature where up to the last 6 minutes of joint movement can be played as a rewind. For example, it may take the user a long time to get the arm inside the window of a car, and there may be lots of pauses, looking around to ensure it doesn't collide with outside objects. When the user is ready to return the arm, using the rewind feature will bring the arm back the same way it was deployed, but cutting out all the pauses. It does not consider the gripper, so if the user picked up an object it won't be dropped during rewind. Any of the advanced behaviors can be stopped at any point during motion as well. The arm is capable of fly the gripper, which means that instead of being used switch by joint, 1 button, 1 joint is moved. The left and right joysticks on the game-style controller can move multiple joints at one time, flying the gripper to an object using the video perspective from the palm camera. Lastly, the robot can be operated in several different modes, including drive, arm, video and graphical user interface or GUI. This mode allows the buttons on the game-style controller to navigate and select the icons on the screen, if the touchscreen feature of the monitor were to fail. Most of the controls to the robot can be accomplished in drive mode. Manipulator mode does all of those controls with the exception of drive and video mode controls, all the camera and light selections without using the touchscreen. The byproduct of having multiple modes is that more than 1 game-style controller can be used at the same time, which makes the controller multiplayer. 1 person could drive the robot, another could control the arm, and a third could be managing the camera views. All of these behaviors combined reduces time on target and overall training time needed to become competent with the robot and all its features. Our 4th focus was on serviceability and support. Remotec has always been very repair-forward. We strive to minimize downtime by designing in a way that allows the user the ability to maintain and repair so that parts do not have to be returned to Remotec. In the early prototype phase of FX, we involved our manufacturing and service groups to provide feedback of each of the arm and chassis assemblies. Prototype parts would come in and manufacturing and service would assist in building the kits and then provide individual feedback and recommendations that would increase assembly or repair time. This resulted in not only streamlining manufacturing but also further enabling field service repairs and maintenance right out of the gate. FX is virtually maintenance-free. There is no need to perform specific tasks at such close intervals as our other products because the software stops the mechanical joints before they reach their hard stops, which reduces the mechanical wear and tear that would cause hardware to get loose or internal damage to occur. Almost every component is plug and play, which means, with a set of instructions or over-the-phone guidance, they can be replaced in the field. FX has a combination of detailed diagnostic screens accessed from the OCU that identify specific faults, reducing the troubleshooting time and tools often required for an advanced platform. We took the time to design these abilities during the early stages, which has really helped to confirm reliability in the field. Overall, FX is a very robust, capable platform that continues to outperform the competition and is unmatched in its size class. Please contact the Remotec sales group for more information or to schedule a demo. Let us show you how the next generation of unmanned ground vehicles should perform.